In this tutorial, we're going to show you how to define a new endonuclease for Casper. So I've just opened a terminal window to get to the Casper app folder. If you have the precompiled package, you can just launch the program that way. But I'm inside my virtual environment. I'm just going to type python main.py to launch the program. And the main window will pop up. So first I'll show you that if you go into New Genome and you click on this drop-down box, you'll see all of the available Cas endonucleases that are preloaded into Casper. Now, if we want to add a custom one with its own guide RNA parameters and PAM requirements, all we have to do is go to the main window here and then click on Define New Endonuclease. That will bring this window open, and then you can give details on where the Cas enzyme was isolated from, its abbreviation, what you want to name it, the type of CRISPR system it corresponds to, as well as the guide RNA details for that Cas enzyme, and the scoring algorithms that you want to use when scoring the guide RNAs for that Cas enzyme. So we'll just go ahead and say this one was isolated from, let's say, E. coli. We're going to call it my Cas. And then let's say it came from a 1E system. Now this seed length corresponds to the region that is most crucial for binding. For SP-Cas9, we consider that to be the first 16 nucleotides, but it can vary depending on the Cas enzyme. If you get confused or unsure about what the fields are asking for, you can always hover over the terms, and tooltips should direct you for what you need to know. So for this, let's just put in the normal 16 seed. 5' length means the amount of base pairs upstream of the seed that belongs to the guide RNA. So in Cas9, because the PAM is on the 3' end of the sequence, there's a 0 base pair overhang, and then 4 variable, what we can consider a tail or variable region at the end of the guide RNA that's not as crucial for binding. So 16 plus 4 equals the 20 base pair guide RNA that we're all familiar with for SP-Cas9. So this can be whatever you want. We'll say that maybe we have a seed length of 16 and then a variable 8 nucleotide region at the 5' end, and then we'll say this has a 3' PAM sequence of NNGG, and then you can select the directionality, whether the PAM's on the 3' side or the 5' side. And then we can select the scoring algorithms we want to use for this. I'm going to stick with the default, but if you wanted to upload your own scoring matrices, you can do that by editing the Casper info file that's found within the application folder and just adding the matrix to the end of the file. So we're going to click Submit. And now if we go back to New Genome and open this endonuclease box, we'll see that our PAM has been added here and that we can now analyze organisms using this PAM. And you can select a file and add the job to the queue and run the job. And then you'll be able to generate guides for this endonuclease for all of your organisms of interest. Hopefully this helps you, and we'll see you next time.